Hi, welcome back to another Core 4 question walkthrough. Today we're doing 3 separate questions from 3 different practice papers, and I've been given these questions from a viewer, and I hope these questions are not copyright infringed because it doesn't appear to be official MEI stuff. It's more like some teacher made up some question or changed some of the past questions to challenge their own students. So I hope I don't get sued for that. But without further ado, let's get on with the first question, which is question 9 on this particular paper. So question 9, beside a major ruined country town, the authorities decide to build a large pyramid, and this is the pyramid. O is the center point of the horizontal base, and you can just read that off yourself with all the coordinates of the vertices. The pyramid is supported by a vertical pole, OA, so O to A. Okay, fair enough. Also support rods from O to points on triangular faces, so the 4 lines. So question is, write down the coordinate of M. M is the midpoint of BC, so that's just, well, one marker, naturally. Write down the factor A to M, which again, it's really straightforward type of factor calculations, and hence find the coordinates of point N, which divides AM in 2:1 ratio, which again, pretty simple. Show that ON is perpendicular to AM and BC. ON is perpendicular to AM and BC. So basically you want to say that the normal of the plane ABC is factor ON. Hence, write down the equation of the plane ABC in its simplest form, which is, well, following on this part. Then finally, find the angle between ABC and the ground. So, let's get on. Let's start with part 1, finding M. That is really simple, because it's just normal geometry, which is just adding the 2 coordinates and divide by 2, take the average. So 4 plus minus 4 is just 0 divided by 2, because average divided by 2. And we have minus 4, minus 8 divided by 2. And finally we have 0 plus 0 divided by 2. And therefore M is just 0 minus 4, 0. That's 1 mark. Then part 2, find AM. AM is just factor M minus A, which is 0 minus 4, 0. Take 0, 0, 6, which gives us 0 minus 4 minus 6. And now, because AN to NM is 2:1, we need to find N. And to find N, we know that because we have the direction factor, and we know we can calculate the magnitude between these two, then we can do a comparison. So the coordinate of M is just from 0, 0, 6, add the direction factor, and this is the unit length that we're using is A to M, because the way we calculated it use A and M, or the other way around, M and A. and therefore this is the unit vector. And because we know that a to n, n to m is an to nm rather is 2 to 1, and therefore we know that this, in order to go to n only, have to go 2/3 of the way. So that would be 0, 0, 6 plus 2/3 of the entire path. And that gives us 0 minus 8 over 3 and 2. So that's the coordinate of n. Okay, so turns out that this paper is kind of not well made, because over here this is clearly ratio an to nm 2 to 1, but over on the answer bit it tells you the ratio is 9 to 13, and that is clearly not 2 to 1. So I struggle to see how this answer will be right, or there might be an error on the question paper itself. So I have absolutely no idea, and that doesn't look anything like it would. So if you got the previous part 2 with my answer, then you are reading the questions right, because the answer clearly does not agree with the question doesn't agree with the answer. So from part 3 onwards, I'm gonna use their answers, because it seems like I can only use that to go on to proceed to further parts. So if you're doing this paper, then please go and check it with your actual teacher to see if this question is misprinted or something like that. So back on to part 3 using their answer for n. Let's show that they are perpendicular to AM and BC. So previously we have found AM. I do not think we have found BC yet, so let's do that. Speaking of B, I wrote A. BC is just the coordinate of C. For minus 4, 0, take away B, which is minus 4, 0. And that would give us 8 minus 4 minus 4 is 0, and 0 minus 0, clearly 0. So we've got 8, 0, 0. Okay, so let's do the calculations. Using the dot product, we can find the angle, and if the dot product, the top of the dot product is 0, then it is perpendicular. And the exam board is where they allow you to just do the dot product without the magnitude at the bottom. And if the top is 0, then they will give you the mark. So let's do that. N is 12 by 13 of 0 minus 3, 2, and we dot product this with 0 minus 4 minus 6. And the dot product works by the first number multiplied by the first number of the other matrix. So the first number is 12 over 13 times 0, which is 0, times 0, it's just 0. Add 12 over 13 times 3 times minus 4. Negative cancels, so I've got 12 over 13 times 12, and add another 2 times 12 over 13 times minus 6, so that is times minus 12. And if you just plug that all into the calculator, it gives you 0. And if you are not using a calculator, I do not know why you won't. You can just factorize out a 12 by 13 to get 12 by 13 multiplied by 12 minus 12, which is clearly 0, because we can do subtraction easily in our brains, but we can't do these kind of multiplication that easily. So now we have shown that this equal to 0. You can add a note to say, so cos theta equals 0, and therefore theta is 90 degrees. These are extra. They, if you just leave it here, I think they will give you the mark. I'm pretty confident anyway. So now let's do for BC. So for BC it's a bit easier because you do not actually need any calculations. 0 minus 3, 2, dot with 8, 0, 0. And the good thing is, because this value is 0 times a number, this is a number times a 0, this is a number times a 0, so you get 0 plus 0 plus 0 as the dot product, and you get 0 clearly. So same conclusion, and the that's part 3 done. Part 4, we want to find the normal factor of the plane A, B, and C. And according to previous parts, because ON is perpendicular to both AM and BC, and all 4 of those points lie on the plane of ABC, we can confidently say that factor ON is perpendicular to the plane. And it's the direction factor that matters. So the ON factor is 0 minus 3, 2. So 0 minus 3, 2 can be used for the equation. And using just basic knowledge of the plane equation with the normal, we know that x have a coefficient of 0, y have a coefficient of minus 3, and z have a coefficient of just 1. 2 rather, sorry, I read that as z for some reason, equals to a certain value k. And we need to put in the numbers in order to find what k is. So let's use a as our coordinate. So 0 times 0 is 0, minus 3 times 0 is 0, plus 2 times 6 is 12, equals to k, and therefore k is 12. And so the plane equation will be 0x, just ignore x, minus 3y plus 2z equals to 12. And that is part 4 done. Finally, part 5, we need to find the angle of the ground, and I have extracted the normal factor of A, B, and C from previous parts so that we can save some time. Now, the ground is a troublesome word because most people can't actually understand the concept of the 3D system. So the ground is flat, as the diagram suggests, from O to Y and O to X, and therefore it has the plane equation of 0, 0, 1 or 0, 0, anything for that matter. This is just the unit factor. And the reason that it has this equation, or this plane normal factor, is because no matter where you are on the plane, x, y, anywhere, any coordinate, any combination, it's not going to matter, because you're just going straight up. It doesn't matter where you are, you're still going straight up. and therefore x and y are 0 values, and z is the height, and it is y it's going up is +1. If it's going down, it's -1, and just rinse and repeat. So for this, we need to find the angle with the ground, and to find that, first let's envision the plane as we rotate this this diagram horizontally, so that we have a view cutting right through AMO. So O is here, A is here, this is M, and this is the angle we want to find, and we have the factor, normal factor over here, and we have the normal factor over here. And if we extend these, they do meet by definition of geometry, because they're not parallel, and they do meet. And the angle we can find, because 0, 0, 1 is going straight up, and 0, -3, 2 is going from O to A, or O to the plane, and therefore it's going this direction and this direction. Or maybe I should extend that as a diagram like this. So these are the two directions, and for an angle to be calculated, it have to be going outward from a junction point. So if I have two factors going this way and this way, then the dot product rule will work. But if I have a factor going this way and this way, then the dot product is going to find me this angle, and that's not what we want. And therefore, to find this, well, technically it is what we want for this matter, but I will just go the long-winded way just for safety reasons, because skipping step is always not safe. So let's flip the arrow around. So we have two options: flip this one or flip this one. Both going in and both going out will work with dot product. Let's flip the easier one, the 0, 0, 1, and turn it downwards. So we have a -1 lots of 0, 0, 1, which is 0, 0, -1. And dots that with 0, -3, 2, that's the normal factor of O to N, divided by the magnitudes. Now, the magnitude of this is unit factor, because we defined it to be, and we're multiplying by -1, which is a directional thing, and it has magnitude 1 anyway. So 1 times 1 is just 1, so I've got 1 unit factor, and multiply that by the magnitude of this, which is 3 squared plus 2 squared plus 0 squared root 9 plus 4, that's 13 in the root, so we have root 13 at the bottom, and that all equals to cosine of theta. So let's do the dot. 0 times 0 is 0, then 0 times -2 is also 0, then we have -1 times 2, that is -2, divided by root of 13 equals to cosine of theta. And if we do on the calculator, set your calculator to degree mode, because our brain works better with degrees than radians. -2 divided by root 13 give us 123.69 degrees. So 123 degree or 124 degree seems like a massive angle, and it is. It is larger than 90 degree, because we made it so that it is a big angle. And the angle we want is over here, which by the laws of internal angles is 180 subtract by this theta. So the angle is equal to 180 subtract by theta, which gives us 56.3 degrees. And so that's conclude this question, and we can move on to the next paper. The second paper, it's question 8 that we want to do. So the height of the tide of the entrance to a harbor on a particular day can be modeled by the function h equals to 3 plus 2 sine 30t plus 1.5 cos 30t, where h is measured in meters, t in hours, and 30t in degrees. Right, that makes sense. In degrees. Okay. Now, I am surprised to see that it's talking about degrees, because usually in order for you to use these kind of functions it have to be in radians, but I will just trust this question for now. It's a bit dodgy. Yeah, it is really dodgy, to be honest. Show that 2 sine 30t plus 1.5 cos can be written in the form of that, so that's compound angle formulas. And you need to find alpha. That's straightforward, can be degree or radians in fact. Find the height of tide at high water and the first time that this occur after midnight, so find the maximum. Find the range of the tide during the day, so the amplitude plus and minus. Sketch the graph of h against t, so diagram between t equals 12 and t equals 0, and indicate maximum and minimum points. Then if just find the time when the water is higher than 2 meters for part 5, and finally part 6, estimate the time at which the water is falling fastest and the rate at which it is falling. So just reading this, there are nothing wrong with using degrees. It's just, other than strange, I have no words. So you're also only estimating and not calculating the rate, and therefore you do not actually differentiate this, so it's not going to interfere with, it's not going to have any problem dealing with the degree instead of radians. So let's get right into this question. Part 1 of this question will be just to make this as a compound angle. So the easy way will be to say that r is equal to, this whole expression is equal to r sine, because it's given, 30t is r theta plus alpha. And when you expand this whole thing, you get r sine of 30t cosine of alpha plus r cosine of 30t sine of alpha. And that, when you compare coefficient, gives you 2 equals to r cos alpha, and 1.5 equals to r sine alpha. And when you do the bottom divided by the top, you get r over r, which is 1, sine over cos gives you tan. Tangent of alpha is 1.5 by 2, that's 3 by 4. And therefore alpha, make sure you use degree mode because the question states so. Gives you 36.9 degrees. And therefore R can be found because the cosine of the alpha is 4/5. So 4/5R is equal to 2, and therefore R is 10/4, 5/2, which is also 2.5. And so conveniently we can conclude that this whole expression equals to 2.5 sine of 30t plus 36.9 degrees. So part 2, find the high tide, the time at which high tide happens. So to find that, we need to find actual h. This is just the expression for the sine and cosine. H includes a +3, and so we update this equation. So when tide is highest, this sine complex thing equals to +1 because that's the maximum that a sine can be. So 1 equals to sine 30t plus 36.9, and therefore arcsine of 1 is 90 degrees. And rearrange this to 30t equals to 53.1, and t equals to 53.1 divided by 30. And that gives you 1.77. Make sure you use accurate values as much as you can. I have been using a rounded version. Probably should use more than 1 decimals, but just use the accurate thing when you're doing your exams. So t is 1.77 hours, and if you convert that into minutes, which is multiplied by 60, you get 106.2 minutes. Which is the equivalent of 1 hour and 46.2 minutes, or 1:46 at just after midnight. So that's the time. And now let's do part 3. Before we jump into part 3, I forgot about the part that I need to find the actual height at the maximum. So that is pretty simple because sine thing is 1, and therefore 2.5 plus 3 is equal to 5.5. So that is the maximum tide height. So doing part 3 now, find the range, which is really easy because the range is just the max height subtracted by the lowest height, and the lowest height is when sine complex is -1. So the lowest is 3 minus 2.5 times 1, well, or 2.5 times -1 plus 3, which equals to 0.5 meters, and therefore the range equals to 5.5 subtract by 0.5 gives you exactly 5 meters. And now we sketch on part 4 between 0 and 12. Make sure you use your rulers when you're sketching a graph. This is h against t, and let's find where it starts. So when t is 0, we have plus 3 plus 2.5 sine of 36.9, and that is 4.5. And relatively our maximum is 5.5, our minimum is 0.5, and 4.5 is here-ish. And to do this curve sketch, we need more information. Luckily, we know from previous 1 hour and 46 minutes goes to maximum. So maximum is pretty early. This is the 1.77, I remember. And it looks like it goes straight up to the maximum. Then it goes down to the minimum. And it goes back up. And at t equals 12, if you put in the number, then 2.5 sine of 30 times 12 plus 36.9 plus 3 is 4.5 again, so it goes back up to its original height, which is right about here. And excuse my horrible sketch, make sure you use whatever you can find to make sure you sketch a accurate graph. And it is also very helpful if you have a graphics calculator because then you can just use those to calculate. Make sure you have your equation correct. And yeah, that looks about correct from my graphics calculator. And yeah, that's part 4 done. Okay, so for this one we need to find when h is more than 2 for part 5, because the boat can only enter when it's 2 or more. So let's find that when h is 2 equals to 3 plus 2.5 sine 30t plus 36.9, and you just subtract both sides by 3 to get minus 1 is 2.5 sine the bracket, and you can rearrange to find, I'll just skip a step here to just go for the brackets because I know it's minus 1 divided by 2.5. So the bracket 30t plus 36.9 is equal to minus 23.578 degrees, and on a sine graph, minus is just on the left of the y-axis, and therefore if you add 2 pi you get this. If you add 360, sorry, you get that part, and if you do 180 subtract by this negative value, then you get the one on the left. So yeah, let's find that those two values of x. So let's see, if I do 180 subtract by my previous answer, that should give me 203.57 degrees. And also, if I did the other method, I get 336.42 degrees. So I've got two values of 30t plus 36.9. So let's find actual t. So let's start with this 203.57. I'll just use the rounded version. Again, use as accurate as you can in the exam. That will give you t is 5.5. 5.556, and for the one on the bottom, t will be 336.42 subtract by 36.9 divided by 30 gives you 9.984, and you have the two times. So with the aid of your previous graph, which looks sort of like this, goes back up quite a ways, we know that the time at which height is 2 is 5.56 and 9.98, and time at h is 2 is just here, and therefore the time between the two t's are actually the time that the boat cannot go through. Therefore, in order to find the time from midnight that you can go into the harbor, that is just 5.556 hours that you can go through. Then you have another, this is up to 12, isn't it? So that will be 12 minus 9.9, that is 2.016 hours. And I forgot which time, what kind of time they want, if it's before, like the first time that the first continuous period that you can drive your boat into the harbor, it would just be 5.55. If it's the entire 12-hour period, then it will be 7.57 hours, and you can convert that into minutes to get a better hour representation. Part 6, I have to admit, it's practically impossible for me to do on a computer, and therefore I will in fact give up on this part, but I will tell you how to do it if you actually have pencil and paper and you have graph papers. So for this question, you want to estimate the time at which the rate of falling is the greatest, and from the rate of falling, you know it is the gradient, so it have to be the max gradient around the middle between the maximum and the minimum. So technically, if I remember the two numbers that I have calculated, which I do not, then I just take half of the average and get this value of t. And in order to find the max rate, you cannot differentiate because it is in degree mode. Again, I dislike this part very much, and you have to draw a eyeball tangent to the curve, which from previous experience is not possible on a computer, and the error is way too big, and therefore this is just, I'm just gonna tell you, go ahead, draw yourself a tangent and measure the gradient using, I don't know, scaled, just measure your scale and things and just calculate it. I know it is a horrible way to put it, but this question is just practically impossible to do on a computer. So I'll leave these 3 marks for you to solve. Finally, we have the last question, and for this one it's question 9, and specifically part 5. So show that gx and g to the minus 1x cross where x is minus 1 plus root 2. And I would think that you will have g to minus 1x already, so I'm just gonna take that from the answer. Okay, for this one, we need to know that the inverse function is a mirror image along the y equals x line. So this is y equals x, and when you have a equation that goes through this thing, say it is, well, I don't know, some sort of line like this, then it will go through itself along the y equals x line, because it is a reflection along the y equals x line, and that point is the thing you want. So the only thing that you can do, because you cannot invert x squared times x plus 2, then you will have to use the equality of y equals x, and it also equal to this function, and therefore y equals x squared times x plus 2 equals to x times x squared x plus 2. Y equals x, and it will be extremely tempting to just divide by x, but that is not a good way to do things, because you lose information from doing that. Instead, you subtract by x. So let's expand everything on the right. X squared times x, x cubed plus 2 times x squared, 2x squared, and minus x equals to 0. Now we can factorize. First, take the x out, we get x squared plus 2x minus 1, and this thing cannot be normally factorized. So we use the quadratic formula, minus b plus or minus the root of b squared minus 4 ac. A is 1, so I ignore a, divide by 2a. And that will give me minus 2 plus or minus root 8, because it's minus minus is plus, so 4 plus 4 is 8 over 2, and that gives me x equal to minus 1 plus or minus 8, root 8 is 2 root 2 over 2, and the 2 goes, and therefore I'm left with minus 1 plus or minus root 2. Now, what you need to know is this is not enough. You need to state why it is minus 1 plus root 2. And the reason is, if it's minus 1 minus root 2, then it is a negative number. Minus 1 minus root 2 is smaller than 0, which is outside the domain, and therefore it have to be minus 1 plus root 2. And that is the answer to this last question. And that's it. To be honest, I really think that these questions are harder than it have to be, because most of the time these questions will not be asked in this format and in this language, because it's kind of old styled A-level stuff. So if you can't do these questions, then please do not just panic about it, because it's more likely that you will be able to do the official MEI OCR core 4 questions compared to these ones. The angles are ridiculous. I cannot understand how they are supposed to tell you to do the second question that I did without radians, and it's just a really giant pain to do. For question 1, again, well, question 9 on the first paper, please do let me know is the question flawed or not, because I do not think it is right, because nothing of that have any resemblance to what I know about maths, because 1:2 ratio is not a 9:13. It's just different. So please do check it for me and let me know in the comment. But other than that, thank you very much for watching, and I will see you on my next one.